Okay, maybe we can start. So thank you for joining. So since we have a very small room, so we can maybe try to make it interactive. So I do have some contents, and I'm from AWS, but the content is more like AWS agnostic because I want to share some more like general practices. So my name is Tingyi. I work as an enterprise solutions architect from Amazon Web Services based in Stockholm, Sweden. So I'm flying all the way here to meet some customers, but at the same time, like coming here to meet some of my colleagues and of course, meeting you guys. And today we're going to talk a bit about practices for generative AI in highly regulated industries. But we're not going to focus too much on like responsible AI and all these things, because I guess you already attended some of the sessions. Instead, we're going to focus more on the application side. So how to deploy LLMs, how to secure your applications, this kind of stuff. Yeah, so since we have only like 30-40 minutes, so let's be quick. Yeah, so you already know like generative AI brings a lot of new exciting opportunities and innovations, but at the same time, we've been talking about the risks and also the challenges, right? Before we go into there, first of all, because I have done this talk before and I didn't mention what are highly regulated industries. And then at the end, I got questioned like, what exactly, after all the things I talked about, they were like, okay, what exactly are highly regulated industries? So here I have a snippet of definition. But in short, so these are industries with government regulations, compliances, standards, and laws in place for consumer protection, public safety, fairness competitions, and also environmental conservation. So some of the examples can be like finance, pharmaceuticals, healthcare, defense, governance, utilities, etc. So wondering like any of you maybe work in the industries, or I guess you are working with financial, absolutely. And you are also?
Yeah, supporting utilities.
Utilities, exactly. In the US?
In the US, right?
In the US, okay.
Soon to be public companies, Switzerland.
All right, okay, gotcha. All right, and the reason why these industries have these regulations, one main reason is because they have sensitive data. And in machine learning, your data is just as good as you are, right? And data is important, and there are different types of data where you need to treat them differently, especially when it comes to sensitive data. So for instance, like PII, personal identifiable information. So those are the data like credit card information, names, biometrics, government ideologies, sexual orientations. So these are the information you probably think of for how to process them, how to store them. Maybe you need to redact them, right? So these are like common practices. And also in financial, for instance, from an organizational perspective, for business, so any data that could potentially influence the stock price could be considered as sensitive data. So it should, especially for those ones that are listed, so the large ones, right? And within healthcare, of course, like you have HIPAA regulations. That's where you need to like how you handle the patient's medical records, etc. And of course, in Europe, we have GDPR, which is like the basic one about personal data. Within finance, there's PCI DSS, for instance, for to protect cardholders' data and to ensure the secure handling of payment transactions. And of course, within defense and government, they always have their own, like they define their own set of policies and criteria about the different classification of data, like medium, low, classified, etc. So because of all these data in these industries, that's why they have this stringent data privacy regulation and also the subsequent requirements on data governance, model hosting, etc. So that's additional challenge that we need to address when deploy Gen AI application and workloads. And if we take a quick look at the AI legislation landscape, so start from the beginning, like 2010s, 2015-ish, GDPR, that's a basic one from EU. And just this year, so we have a EU AI Act, which is a big thing. And just this year, early this year, it has been passed through law. So now it has become an official law as part of EU. And also from US, there is Stop Discrimination, which is released just here in DC, 2023. And the same year, it goes into Algorithmic Accountability Act, which is for the whole FAD, so the whole US. This is really about understanding the inner mechanism of AI, so understanding what exactly is happening there, try to interpret the black box. And of course, like UK has their own thing, and here United Nations released this one about like human rights. So you see like how this evolves. So now it has become like a global force, global team. And what you need to notice, like you don't only care about say, okay, maybe your companies are mainly based in US, but you also need to care about where you're doing your business and to be compliant with all the regulations and laws over there. And this is like the overview, like where these countries have passed legislation like that. And that's why there's a few pillars that we'll be talking about a lot, like hallucination, toxicity, safety, intellectual property, and data privacy, right? And some top requirements that we have seen for highly regulated industry customers or companies, based on, because they need to be compliant with all these regulations, I just list top three, like asked for us, because I work as a customer-facing role, right? A lot of customer, highly regulated ones, they want to host models in-house. So meaning that they cannot just use OpenAI API or some API over there, because they want all data transmission, all the data stay in their corporate network or stay in their own environment. So that's top requirement. And also how to secure GenAI applications, right? To make sure that the whole application and also your building blocks are fully compliant with all these compliance and regulations. And also model explainability. So transparency, interpretability of the model to understand why the model is making certain predictions. So these are the three we're gonna dive in here. So here I have this like three aspects. So responsible AI, you can regard these two as like a subset of the responsible AI, right? But let's say responsible AI is more about like shared responsibility between you and the model provider, and also, you know, some MLOps practices. And secure AI is more like securing the GenAI applications. Explainable AI is about transparency. And if we look at the GenAI application, there's more than just models, right? But models, foundation models is at its core. There's a lot of other parts. So if we look at model first, which is at its central. When we talk about hosting options, a lot of people were like, okay, I just call an API, right? Like Anthropic, OpenAI, there's a lot of APIs out there. But many regulated customers, they cannot go with hosted APIs. Like hosted one, you can say like OpenAI, Anthropic, AI21 Labs. Basically, you just call the API. They take care of all the heavy lifting for you. You don't have to care about scalability, deployment. Of course, there's some like maybe hallucination reduction you have to do, but essentially you benefit from all the underlying works done there by their fantastic engineers. The other option is what we call in-house hosting or self-host option. Basically, like you call one of these open source ones like Mistral, or you host a Llama, or some of the options from Hugging Face in your own environment, either like a VPC in the cloud, or maybe on-premise, or in your corporate network. So there are some benefits. Why do you want to do self-host? The first reason, of course, maybe is your compliance team hard requirements say you have to do that. But there's also other benefits. First, second, you can benefit from decreased cost. So it is true that if you only do like a POC, then it's cheap, very cheap to just call an API, just to test it out, right? But when you deploy it at scale, then using a self-host model is much, much cheaper. The reason is because when you do at scale, you are focusing on your particular use case. That means that you can use a much smaller model instead of an OpenAI model. For instance, GPT-4 is a very capable, phenomenal model, but one of the reasons also because it's very broad. It can do writing Shakespeare, it can do coding, it can do mathematical questions, so it can do everything. But you don't technically need all these things, right? You just need something that is capable to do whatever use case that you want, maybe text to SQL, or maybe, I don't know, produce some JSON outputs. And in this case, you use a smaller model, you benefit from decreased cost. At the same time, you might also have improved performance. So here I have a few like screenshots from some blog posts. So basically, you can use these smaller models, which is fine-tuned or tailored towards your specific use cases. For instance, here I have a fine-tuned of text to SQL using CloudLlama and surpass GPT-4. So that's where you you focus on niche use cases where the model capability can be increased. Right? I hope that makes sense. Okay.
One quick question, like any insights of fine-tuning large models, like Llama is pretty large model, so the cost associated with that would be huge, right?
You were talking about, like, for instance, Llama 70B.
Yeah, yes. If we
What-
take that, for example.
Yeah, absolutely. I mean, of course, compared with like previously BERT or something, it's still pretty large, but we're talking about comparing with the GPT-4. That's billions of parameters, and then that's definitely like a lot less, right? It's only like 16 gigabytes or 10 gigabytes each. If you use like 7B, that's only 4 gigabytes. So comparatively, that's much smaller. So that's what we're. Okay, then with this in mind, of course, there's some other benefits as well. And this is the report from this VC Tingyi. So basically, enterprises care about open source due to mostly 3 reasons. So control, customizability, cost. And the main reason is control. So basically, you have that AI independency. So let's say if OpenAI decide to fire their CEO again, then maybe GPT-4 is not available anymore. You have the control over there, right? And of course, like if you fine tune it, it will be your intellectual property, etc. So basically control the data, the output, and everything. And also for those enterprises, we're talking about in general all enterprises, not only just highly regulated ones. Even if they are not using open source now, they're very actively eager to use them in the future because they're still waiting for open source models to be on par with GPT-4. So they're waiting for that to be catching up. But we're seeing it's very promising. For instance, Llama 3 400B is on the training, right? And it will be released later this year or maybe next year, which that's what they are like having their eyes on. And of course, model hosting is challenging because there's always this triad where you need to kind of trade off in between. So if you use GPT-4, which has good performance maybe, but it will cost you a lot and also has high latency. So there's always a trade-off. So you need to care about what is your priority, let's say. So to begin with, it's always to work backwards, right? You need to start to think about what's your latency requirements. So the bare minimum. So what's your tolerance, right? For instance, a range. Maybe you say, okay, I'm okay with my latency to be below 1 second and above maybe 300 millisecond-ish. So like have a range there. And also the expected load. So for instance, like how many users are we talking about? Is it like at peak 3 users or millions or billions of users? And also what kind of hardware you have available? How much can you afford, right? If you use a cloud instances, which one you want to use? So after you just start to think about this, then you know, it will help you to kind of determine which model. And then if we go to some practical best practices, maybe not the best, but practices. So first one is always use quantized version. Unless you have like no budget limitation or anything. So hands up, you know what is quantization, right? Exactly. So quantization basically means model compression. So you can reduce the precision of model weights to whatever you want, basically. There's different precisions. And here is a paper published by David Detmers. So this guy is quite a genius. So basically saying like, okay, how these different precisions will impact model performance and a trade-off. And if I zoom in, maybe this picture. So 4-bit, basically the title already kind of alerts everything. So 4-bit is the best because 4-bit is experimentally approved to be having the best compression and accuracy trade-off. So if we look at this picture, so for given, so model bits versus accuracy, so basically given certain resource size, as you can see, then FP16 is the lowest trade-off, as you see, based on accuracy, right? And FP4 is the 4-bit is the best trade-off. So basically, this graph is telling us that given a particular resource size, you are way better having a quantized model version of the same size than having an unquantized model version. So if we take it as an example, so we talk about working backwards. Let's say if you have a L40S GPU available, and that's 48 GB VRAM, that's our hardware. Okay, now we start to work backwards, right? Okay, we look at a few model options. So first one, Llama 13B, 26 GB. Okay, that's good within our limitation. Mistral 90 GB. Okay, that's too big. And then we also look at the quantized version, which is 22 GB. So it's quantized version of this one. So these two both works, but you are probably likely to choose this one because when given limits, so given similar sizes, because this model retain a lot more accuracy from this much larger model and quantized down, right? So it's kind of compressed down. So you're probably very likely to have much better accuracy out of this model instead of this of the same size. So that's basically what this paper is trying to tell you. So go with quantized one because they retain higher accuracy from larger models. And the second practice is to always optimize your inference. So basically our goal here is to maximize GPU utilizations. Because GPUs are expensive, you need to make sure there's not so many idle resources all the time. I'm just gonna give you some examples. For instance, bashing strategies. So that's one of the typical strategy we need to have when using these models. So if we go with no bashing, this is the graph. This is the GPU utilization you're gonna get, very low, right? And if we go with dynamic bashing, so this dynamic bashing before GenAI, this is the most popular one, or like the default one for most of the libraries. For instance, if you use Hugging Face accelerated libraries, this is the one that they're gonna apply by default. But for GenAI, this is what you're gonna get. So basically, dynamic bashing is like they group all these requests together and then process them in bash. That's why they have a lot of queuing time. You see, the GPU utilization is like a wave. So there's still idle times, right? But better than the bashing one. And recently, there's a new one called continuous bashing, which is a specific technique designed for generative AI. And you see, this is a takeoff, right? This is much better than dynamic bashing. It's basically state of art. And this one's because basically you let all the incoming requests, like you don't have to queue them, you just continuously bash them and then distribute them across like multiple GPUs. And in this case, you have much higher resource utilization. So just make sure you always have GPU utilization on ice. So this is a very important metric. And of course, like parallelism strategy. So here I'm gonna jump quickly. So it's really just about like you have because these are large models, large LLM, right? L stands for large. So basically you have to use multiple GPUs. Let's say Llama 7B, it's quite of a small model, basically. You still need like, if in production, you probably need 4 A10 or something GPU. So still like multiple GPUs. So parallelism basically just say how you should parallel, like having all this computation, like matrix computation in parallel to make sure all the GPUs are in use, not just idle. And tensor parallel is one of the state-of-the-art mechanism. Yeah, so these are just a few examples, say how you can optimize the inference here. So just make sure you optimize these things to make your inference much faster, and also you have higher GPU utilization. So you spend, let's say you maximize the usage of your GPU, so you don't spend too much money. And also, this is one thing, a lot of enterprises that we notice, so consolidating infrastructure. So basically, all these enterprises, they have a lot of machine learning teams. But the sad thing is that most of them work in silo. And for generative AI, because model deployment is hard and requires a lot of resources, what you want to do is to deploy once and maintain afterwards. So you don't have to deploy multiple times. So that's kind of the ideal case. So what we kind of recommend people or companies to do is like you have, let's say, a central compute infrastructure team, or can be your MLOps team. So they're the one responsible for model deployment. Let's say here, maybe your company say, okay, these are the 3 models that I allow the teams to deploy. And I have them, right? Maybe this team will be responsible for all the updations, blah, 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 over there. And then so all these yellow boxes, they are application teams. So all these application teams, they're trying to develop different use cases applications. And they're probably gonna develop something like LoRa, that's for fine tuning, some rocks, that's where you provide some data. So basically for different use cases. And you want all of them to be able to use the central infrastructure, use the model as infrastructure. So this gives you like an open AI experience, right? All your application teams just call the API. So it's for them, it's just like open AI. They don't feel it's an in-house hosting model. It's still the open AI experience. And as application developer, I don't care about model. I only care about my application, my use cases. I just call the API. And in this case, that's kind of how you have like a consolidated infrastructure where you can call everything, you maximize the deployment. And also in this case, you have a better, much better GPU utilization because all the teams are using them, right, from the central team. So that's basically one of the best practices. And also, when you can use smaller model, so this one we have covered, because if you look backwards, like just 1-2 years ago, the state of the art model keeps growing. There's like keep coming up like all the new models. Just imagine how many models has come out for the past 3 months. It will continuously to be like that. So they evolve at an unprecedented speed. And also the leaderboard keeps changing, right? And this is also from that report that we just seen. So the most companies use more than one. Let's say all of the companies use more than one model providers, because not one model can rule them all, right? So you need to have different models at your hand. And especially when it comes to specific functionalities or use cases, there's a lot of models, smaller models, which are much better tailored to those cases. For instance, like in ROC, there's some models that is fine-tuned or very good at ROC fusion. And also function calling, right? There's a tool former from Meta. So it's fine-tuned towards function calling. And also there's some other models that is tailored to, because not all models has function calling capabilities. It has to be fine-tuned a little bit. So just to say, like, you have to have multiple models and use smaller models. So in summary, these are a few takeaways. But this isn't all the end. So we just talk about LLM deployment. So we still have some time. And then if we go further, so I'm trying to move a bit faster here. So if we go back to this application, we talked about the foundation model part. There's a lot of things surrounding it, like a lot of other things, right? So that's where we talk about like how to secure the application outside the model, because there's a lot of loopholes. There's a lot of vulnerabilities out there. So here I'm just having a few news, which I'm not going to go through, but you see like, for instance, some OpenAI GPT plugin exposed sensitive data. There's also supply chain attack, where it's like, basically, Log4j, right? Like where they lock the systems, and that's where the vulnerabilities were introduced, because hackers can kind of inject codes in there and then have these malicious codes executed on the systems to, perform some harmful attack. So that's supply chain attack. And also famous one, prompt injection, right? From Google, that's a big news. I believe some of you have seen that. So because all these news, all these things, so when we talk about the Gen AI applications, there's more than models. And within each part of this application, there's a lot of potential vulnerabilities that you can see. Some of them are like the same with the traditional security problems, like DDoS attack and stuff. but there's some new ones like data poisoning or prompt injection and the kind of stuff. And here, I believe some of you know this OWASP, so open web application security principle. So they have released a lot of these kind of things, and they have released this top 10 vulnerabilities for large language models. So if you're interested, just go check out their reports. So you see what they listed out. So this one might be unique for LLMs, prompt injection. So it's kind of a cyber attack for large language models, where like hackers can introduce some malicious prompts as legitimate prompts, and then kind of manipulate the content, basically. But there's also like just general one, like DDoS, right? Denial of service, general one, and supply chain attack, general one. So you can see some similarities. And also this is from their report. So from their report, they also list a bit, say, you see, this is a whole Gen AI application. There's multiple places where you can see the vulnerabilities. And here, because we don't have too much time, so let's maybe just go through fast. The best practices, so this is from one of our AWS blogs, because it's about securing applications. Of course, for Gen AI workloads, but there's still a lot of similarities. So basically what you want to do is to introduce security into each layer of your application and to work backwards from your regulations and compliances to say, okay, convert each of these compliance clause into corresponding policies or detective, protective kind of policies that you have. So it has to be layer by layer. And in AWS, basically what we have is that we have services for different stages. So you see from govern, like more like a preventative, all the way to detective and also responsive. So these different stages services for you to kind of protect the whole application. And when it comes to Gen AI applications, of course, there's some like, for instance, data poisoning, supply chain, prompt injection, then maybe you have to care about data validation, input validation, or like encryption, control, etc. And one thing to notice is that there's something called guardrails. We have guardrails available from Amazon Bedrock, which is like our serverless API service for foundation models. But guardrail is a universal concept. So basically, let's say the model might have some, might output some hallucination or like malicious outputs, but you have a guardrail in between your user and your application, your model. And the guardrail will determine, okay, if the output is legit, and if not, it will kind of replace it with legit responses. Say if you ask some questions about a politician and the model might give a biased politician like comments, then you probably want to replace it with, sorry, I cannot answer this question, this is biased. And last part, explainable AI. It's about like a few pillars. So fundamentally, explainability is a set of tools to help you interpret and understand decisions of your AI models make. So basically, if you are financial services or healthcare, when your black box models, if it's a black box, nobody will trust them. Especially when it comes to financial status or health condition, right? So you need to be able to make judgment on the decisions made by the models, and also to see if it's right or wrong, and also to explain to your clients. That is how you earn trust, right? And also reduce risks. And Anthropic, because you know Anthropic, right? It's a company for cloud. So Anthropic is a group of people who used to work for OpenAI, but they came out and they decided to work for security. So that's why they established Anthropic. So Anthropic focuses a lot on transparency, responsible AI security, etc. And they have released several papers around explainability as well as interpretability. So these two are very similar, but essentially you just see interpretability is much harder. So it's about really understanding the inner mechanism. But explainability is more about mapping the input to the output just to, okay, if I can explain the output, that's good. So explainability is easier, let's say. So if you're interested, you can check out this blog post. And to do explainable AI, there are a few metrics that you can adopt. So basically there's different types. So there's model agnostic or specific. So basically agnostic ones that it has nothing to do with model architectures. So no matter it's transformers or convolutional networks or MLP, doesn't matter. So it doesn't look at model architectures. Instead, it only maps the input to the output. And model specific is more to say, okay, look at specific architecture, right? For the transformer or for CNN, like that. And the vertical ones, you have a global analysis and local analysis, which means local analysis is about a particular single data point to predict. And global analysis look at the whole model, the output. So this one is about, let's say you have one data point, you send to the model and then the output. Okay, how about we just look at this one single prediction? And there's a few examples. So Shipley, this one is the most famous and most adopted. That basically is like a plot. It will kind of compare these models, like just to tell you like how the model inputs and the output kind of correlate in some sort of ways. And this one is also famous. This is a holistic evaluation of language models by Stanford. So they kind of have a leaderboard because it's model specific. So this one, I think, focuses only on transformers. And also it's global analysis. So you can see a list of different model architectures and then correspondingly some sort of results that they've done. And also these two look at single data points. So if you're looking into do some explainable AI, so these are some tools that at your availability to do. All right, so that's basically the three parts that I want to cover. Here I have some customer use cases from AWS, but I think I will not go into there. But this is just some example of it. BlackRock, JP Morgan, PayPal, these are financials, right? So essentially, they adopt explainable AI to kind of explain to their clients why our models are making these predictions, so that the clients trust them more because it's about financial decisions, right? And no one knows this. I'm not sure if you know, but it's like Eli Lilly in Europe. So it's quite of a star in Europe. So they're healthcare, they're pharmaceutical. So they use explainable AI to through their pharmaceutical development process. So basically, they have a civil engineer, they have a pharmaceutical engineer. So these engineers will use their domain experts to make judgment on the model predictions, and then form a human in loop to kind of provide feedbacks to the model. So it kind of form this loop to make sure this drug development is in compliance or properly handled. And Ericsson is from Sweden. So Ericsson is one of our customers. Of course, they are a communication customer, telecommunication. But because of Nordics has very restricted laws and regulations, that's kind of a typical thing for Nordics companies. So Ericsson also applies explainable AI in their 5G networks. It's more like AI ops. So basically, they apply this explainable AI into AI ops, so that within their 5G networks, there might be a lot of loopholes or some root cause that you need to identify. And their engineers will use the results from AI and then see, okay, if the loopholes kind of match to what they have identified. And if not, they will also provide feedbacks. So that's one thing that Ericsson has been done. Yeah, just to see some examples. All right. So that's basically the three aspects I want to talk about. Of course, these three aspects are not the whole thing about regulated industries. It's just some examples. But again, it's focusing more on the application side. And these are some highlights, like some key takeaways from the consideration for highly regulated industries. So these are the three main ones. And then we talk about model hosting, some practices, and we'll talk about security of the Gen AI applications using OSWAP, the top 10 standards, top 10 vulnerabilities, and of course, explainable AI. All right, that's the end of it. I'm sorry, I guess because I'm conscious of time, so I go a bit fast, but I hope it's clear for some of you.
Thank you. Thank you.
Okay. Thank you.